So can anyone just confirm if I'm audible? Great. So let's start today's session. So yeah. So everyone just make sure that my screen is visible to you all, and then we can start this session. Make sure that the meeting is being recorded and a video recording will be shared with you of this tutorial session. So I hope my screen is visible to every one of you and I am audible also. So let's start today's session. With joy of computing using Python. So I am using I am Rupesh Kumar and today is Friday, 16 August 2024. So this session will be between 6 to 8 p.m. Okay. So yeah. So one final check. I am audible and my screen is also visible to you all. Everyone just confirm, then we can proceed. Anyone just please type in the chat box. Great. So let's start with today's first question. So select the correct statement regarding magic square. So every one of you is familiar with the magic square problem. So you all have seen the NPTEL lectures related to the magic squares problem. So 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 let's say you have a 3 by 3 grid and you have to fill in the grid with odd digits between 0 to 9. So 0, 1, 2, 3 until 9. You can choose the digits between 0 to 9. They can't be repeated. In fact, 1 to 9, and they can't be repeated. You have to fill the grid such that the sum along along any row is equal to sum of values along any column is equal to sum of values along any of the diagonal. So this is the condition for the magic square problem. So let's look at the first problem. It says select the correct statements regarding the magic square. So the magic square of order 1 is trivial. So what is the order of a magic square? Order is basically the grid size that we are considering. So first problem says what the magic square of order 1 is trivial. So yeah, sure, because you just put in any number and the sum along sum is always that number. So yeah, the first option is correct. Option A. Then sum of two magic squares is the magic square. So no, this is incorrect. Then magic square of order 2 is not possible. This is also correct. Then the magic constant for a 7 by 12 possible magic square is 260. So yeah, so this is not correct. So the correct answers is R, A, and C for this problem. Okay. So let's move on to the next question. For which of the for which of the following matrices would the code snippet return true? Okay. So so let's look at the code. So we have a function def does something and we are taking in a matrix. Then we are computing the number of rows in the matrix by counting the number of elements in the matrix using len function. So r equals to len of matrix. If r is equals to 0 or r is not equal to length of matrix at 0, return false. Okay. Expected equals to some matrix 0 for row. Hmm. So let's break down this code and see what is going on. And then we'll be getting an answer. Okay. So let's write in down this function line by line and try to do a dry run. So we have a function def does something. Okay. The argument is the matrix. What does the function do? We take number of rows equals to len of matrix. Okay. And then if r is 0 or r is not equals to len of matrix at 0, then what we have to do, our function has to do, it has to return false. Now we have another variable expected that is equals to sum of matrix at 0. Okay. Then we run a loop for row in matrix. So we are basically looping through one of each row of the matrix. If and we are calling the sum function at the row for a particular row is not equals to the expected value, then what we have to do? Again, return false. Okay. Then what we are doing for j, so we have another loop j that runs from 0 to the upper limit r minus 1. If sum of matrix at ij for I in range r not equals to expected, then what we have to do? We have to return 0. Achha, return false. Now, lastly, what we have to do, if sum of matrix at r minus 1 minus I for I in the range R is not equals to expected, we have to return false. Otherwise, we have to return true. So this is a pretty complex program that we will go through one by one. So let's try to read it and try to dry run it you on pen and paper and then see what is going on. Okay. So let's say we have matrix and let's say we take the matrix that is provided in the option A 816 357 and 492. So we have this matrix. Okay. Now, what we are saying, R equals to length of a matrix. So how it will be stored in the Python list? It will be stored like this. Each row is a list of this matrix, 816, comma 357, comma 492. Okay. So this is how the matrix is being stored in the Python list. So now what it says, it contains three lists, and each list represents a row value, a row of this matrix. So row 0 is present as a list present in the zeroth index of this matrix list. Okay? So R is len of matrix. That means R is equals to 3. So there are total 3 rows. So total 3. R equals to 3. Now, if R equals to 0 or R not equal to length of matrix of 0, so what this line is doing, what it is doing, checking if the matrix is blank. So what this line is doing, checking if the matrix is blank or if the matrix is not a square matrix. So what this line does, it basically checks either if the matrix has no elements, then also we have to return false. Else, if the matrix is not a square matrix, so length of the that is 3, number of rows is not equal to number of columns, that is length of matrix at 0. So what is the length of the list at the 0th index? So if they are not sent, then this function will return false. Okay. Next. Now we have a variable expected that computes the sum of the values present in the 0th list of the matrix. Okay. So what is the 0th list? X1, this is equals to sum of 8, comma 1, comma 6. This is a list present at the 0th index. So which is equals to 15. So this value is 15. Now what we are doing, we are iterating each row of the matrix. Now, so for each row, we are doing this. And if some of that row, so basically, let's say first row is 816, so it will check some of 816. And which is equals to 15. Then let's say second row, when I row becomes 1, then we have 357, so which is 357. This again becomes 15. Okay. Now, lastly, we have the last row. That row contains 492, 492. So yeah, all three rows satisfy this condition that sum of the values present in the particular row should be equal to the expected value. If this is not the case, then we have to return false. Okay. Now what we do, we run another loop for j in range R. So basically looping through total rows in the matrix. If sum of matrix ij for I in range R not equal to expected, hmm, so let's see what this loop is doing. So what we are saying, if first we are looping through the total rows, so we are going each row at a time. Now, if some of the entries in the matrix at ij, so j is the row, we are fixing the row through this loop. So let's say we are at a row 0. Then the sum of matrix at ij. So in the jth column for the ith row, what is the ith row? Ith is basically total number of rows. If that value is not equal to expected, then also we have to return false. So basically what this line is doing, adding up the values column wise. So basically for this matrix, this value for row 0, it will result in 8 plus 3 plus 4, that is 15, and so on for each of the columns. So it will add up the column values. And if that value is not equal to expected value, then also we have to return false. Finally, what we are saying, if sum of matrix of R minus I, R minus 1 minus I for I in range R is not equal to expected, we have to return false. So what is this? So so R is total number of rows, and then we have to check the sum of the values presented. Let's say if I is 0, then this is, what would be this value here? So let's decode this list first. So okay. So if I equals to 0, then we are talking about the matrix entries at 0, comma, R minus I minus 1. R is 3, total number of rows, minus I is 0, minus 1. So 0, comma 2. This is matrix at 0, comma 2. And we are adding it up for all the rows. So matrix 1 हो जाए. This will be 1. 1 at 1 minus 1. So 3 minus 1 minus 1. That is 1. Plus matrix at when I is 2, then it will be 2, comma 2 minus 1, 3 minus 1 minus 2. 3 minus 1 minus 2 will be 2, comma 0. Okay. Fine. So if this sum is not equal to expected value, we have to return false. So let's check these conditions. The first two are simple. Simply check the total sum of values present in one row. That should be equal to sum of values present in one column. And the third condition is pretty much complicated. So it basically says that you have to compare the value at 0, comma 2, 1, comma 1, and 2, comma 0. So basically the this diagonal, second diagonal. So let me show this here also. So what does this say? The first condition says the sum along each of these rows should be same. Okay? Ek single, they should be same. Then the second condition says these sums should be same, right? Then the third condition says that this sum should be same, equal to the sum of the values along the rows and the columns. Okay. So let's use this logic to check our matrices and return the answer. So for the first matrix along the row, we have sum 8 plus 1 plus 6, 15. 3 plus 7 plus 5 is 15. 4 plus 9.2 is 15. This was along the rows. Then let's do this same along the columns. So 8, 3, 12, 4. 8, 11, 4, 15. And then 5, 1, 6, 9, 5, 9, 6, 15. And finally 7 to 9, no, 15. 15. So yeah, and then across the diagonal also we can check the values. So across the diagonal the value is 6 plus 5 plus 4, which is 15. So yes, this matrix satisfies the criteria. Okay. Okay. Let's go ahead and check the second matrix. This is 2 plus 9 plus 4, that's 15. Then 2 plus 7 plus 6, 15. So you will see that this matrix also satisfies these uh, quantities. So can anyone tell me for the last matrix? Is this true for the last two matrices also? Okay. So when you will check this logic, you will see that all the matrices satisfy this property. So the correct answer is all of them. Okay. So let's move on to the next question. So yeah, let's take a break for 2 minutes and then I'll resume. So yeah, so let's start with the next question. So does anyone have any doubts in this problem? Problem number two. I hope it is pretty much straightforward and you all can solve this on your own by now. So let's go to the next question. Suppose you want to simulate the birthday paradox by generating random birthdays for a group of people. Which library function would you most likely use to create a random integers representing birthdays? So can anyone tell me what would be the function that will you would prefer? So what are birthdays basically? Whenever you say like Ram has a birthday on 10th Jan, so what is 10 here? So it's basically integer value. Yeah, that's true. It's an integer value. And uh, you want to generate random birthdays. So how to declare those generate those random birthdays? We can use random dot rand int function. Option A, random dot rand int. Let's move on to the next question. Which of the following are functions in the datetime module of Python? So what is the datetime module? Datetime module provides some functions that help you to process dates and time data formats. Okay. So in Python, we have the datetime library and let's see these functions one by one. So what is datetime.now? It gives you the current time and position, date. So yeah, this is a correct answer. So it is provided by the datetime library. Then datetime.present. So this is not a library function. So you can it's not incorrect. It's incorrect basically. Then date.today. Date.today gives you the today's date. So this is also correct option. And finally, date.now, it is incorrect. Yeah. So correct answers are options A and C. Fine. Anyone do you have any doubt? Okay. Let's move on to the next question. Question number 5. So it's a programming problem. So I will write code for this problem to you guys. So yeah, Himanshu, do you have any doubts? You are saying no, sir. Fine, great. So question number 5, it's a programming problem where we have to create a we have to create a game where a user can play. So the game is named as the Masked Gun game, and it's a game where the user is given a masked gun. So assume that a gun is placed inside a box or it's masked. Then the computer asks the user for some secret code to unlock that box so that the user can get that gun. Fine. So what are the rules of the game? So no one, only the computer knows that secret code that can be used to open up that box, and that secret code is of four integer digits. Four digit integer. It's a four-digit integer. Then what the user have to what the user is provided with? The user is provided with a set of attempts. So let's say user is allowed 10 attempts, and in those 10 attempts, the user has to guess correctly this four-digit code. Okay. So we are given some set of steps that will help us to write this program. So let's see. The first program says implement game loop. What we have to do, set up a loop for the main game logic, then display the masked gun, then create a function to visually represent the masked gun. Okay, fine. Then we have to generate a secret code, write a function to generate a random four-digit secret code, then provide feedback and manage attempts for guessing, display feedback based on correctness of the guess, and keep track of the number of attempts left for guessing. Then we have to end the game. The end game, if the player guesses correctly or he or she runs out of attempts. Then we have to validate and compare guess with the secret code. Check if the inter digit is correct or not. So we have to write our answer. So basically, these are a set of steps that will help us to write a program Python code for this game. How to question is we have to arrange these steps in such a manner that in the correct manner so that the Python code can be built upon it. So let's see what. So can anyone just type in the correct answer? What do you believe? What do you think? What should be the answer for this? Just type in the chat box. So I'm seeing no answers from you guys. So let's say you have to write this game or Python code for this game. So what would you do first? What would be the first step? What should be the step one? So yeah, someone is saying 231,465. So let's see what is the seat of secrets. The user, you are saying display the mask gun. Fine. Then what we have to do? We have to generate a secret code. So no, first we need to build up the secret code. Then using that code only we can make the mask run. So the correct way would be, so in the step one, what we can do, we have to generate secret code. In step two, what we have to do, we can display mask run. Okay. Then in step three, what we can do, we have to implement. We need the game loop so that uh, the game can be played. Fine. Then in step four, what we have to do, so let's allow the user to guess the secret code. Allow the user guess the secret code and validate if the code is correct. Fine. Give the feedback also to the user. Then in step five, what we can do, we can validate and compare. To use the guess the secret code. So yeah, this step five can be this statement. Validate if the code is correct. So allow the user to get the secret code given that the user has not run out of uh, maximum attempts allowed. Fine. Finally, what you have to do? We have to validate if the code is correct. And then in step six, we can end again. So these are the set of steps that will help us to write us this solution. So let's map them to the given options. So the generate secret code is option three. Then what we have to do? After three, we have to display the mask gun. So that is two. And then we are implementing the game loop, which is one. Step number one. And then we allow the user to guess the secret code. So that is option four. Then we compare and validate. And finally, we end the game. So yeah, huh. So we can validate if the code is correct. And then what we can do, we can give feedback to the user if the code is correct or not. We can give feedback or we can give hints after taking the input from the user. So there will be a change in the answer. It will not be 4 because first we need to validate. Then only we can give the user some feedback. So 645. It will be 321 645. Fine. Everyone, do you have any doubt? No, do you have any doubts related to this question? Great. Let's move on to the next question. To implement a magic square, question number 6. To implement a magic square, we use the concept of matrices. Select all the statements that are true in this context. Okay. So we have to choose the correct option from these set of statements. So anyone please answer these questions in the chat box. Let's see. So one option says one possible implementation of matrices is through nested lists in Python. So yeah, option A is correct. So how do we declare the Python list matrices in Python? Option A. So how does this happen? So let's say we have a matrix that looks like this: 1, 2, 3, 3, 4, 5, and so this is a matrix. So this can be written as a list of lists, nested lists, and each list within the top list contains a row of this matrix. So this is how we can one possible implementation is through nested lists in Python. Then NumPy is one of the standard libraries associated with implemented matrices. No. So it's a standard library that allows you to do some numerical operations on matrices in Python. Then implementation of matrices only through lists in Python. That's not incorrect. And then also none of the above is also not correct. Okay. Fine, everyone, with this. So yeah, NumPy is one of the standard libraries associated with implemented matrices. So yeah, this will also be a correct answer. Yeah, it will be correct answer because NumPy provides you standard matrices and allows you to do matrix operations. Anyone, do you have any doubt in this question? Fine. So let's move on to the question number 7. So let's see this program. So consider the given data set of 60 people born in 2000. Okay. So in the year 2000, we are given a data set. I don't think there is data set of 60 people. It's a data set of 32 people. No. So let's me update the question. Given the given data set of 32 people born in 2000, what we have to do? We have to write a code that checks the count of people whose birthdays fall exactly on Tuesday. So for each person, we are given the birth month, birth date, and the birth year. What we have to calculate first, we have to calculate the birth day. So among like Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, on which day the birthday happens, and then we have to count those the number of persons who have their birthdays on Tuesdays. So let's see how we can write a code for this problem. Hmm. So let's say we are in January 2000, and let's check the calendar. So you can see the first January happens on is a Sunday. So first January 2000 is a Sunday. So now what about 2nd January? It will be a Monday. Similarly, as we go on, the first week will end at say 7, 8 January. and that will be a, what should be it? So it will end on 7th and it will be a Saturday. Okay, sorry. So I made a mistake. 1st January was a Saturday. Then we had Sunday. Then the week would have ended on 7th January. That would have been a Friday. Am I correct? Let's see. So yeah, 7, you all can see that 7th January 2000 is a Friday. Fine. So yeah. So how did I come up with this logic? So we take a starting point. So we have initial value like for 1st January 2000, the day is Saturday. Then as we move day by day, the day gets incremented from Saturday to Sunday to Monday to until Friday, and then again Saturday comes back. So now what about 8th January? So we need a program that takes this date and month and year and tells us which day it would be, given the first day of the year was a Saturday. Okay. So the 8th of January would be a Saturday again, Saturday. Then again, 9th would be Sunday, and so on. Now let's say we talk about what about 24th January 2000. So how many weeks have been passed till 24th? 24. We can get that value by computing 24 modulo 7. Okay, everyone, do you know this? How are we getting this? So, total number of weeks that have been passed till 24th are 3 weeks. Hmm. Uh, Basically, we have to divide this and we have to take the integer part of this value. So this will be 3. So these are the total number of weeks that have been passed since 1st January till 24th January. Fine. Now, so what was the recent starting day recent week's start date, starting week's date? So what would that have been? So that would be 21st January. And what that would be? That would be a Saturday, as our month started with the Saturday. So the first week started with the Saturday. So for every 7th date would be a Saturday. So no, 21st would be a Friday. Huh. So 22nd would be a Saturday. Sorry. The 22nd would be a Saturday. How? It's simple. So how it happens? This happens because, so in let's count the Saturdays starting from 1st January. So the first Saturday would be 1st January, then 1 plus 7. So after 7 days, we get another Saturday. Then after 8 plus 7, that is after after 7 days after 8th of January, we get 15. That is again a Saturday. Then after 15 plus 7, we get 22nd of January. That is again a Saturday. So this is how we reach. We know that the what the date would have been on 22nd January. Now, how many days have been passed since 22nd to 24? So we have passed 3 days. So what should be the day on 24th? It should be after Saturday. We have 3 days. So Sunday, Monday, then Tuesday. So 24th January should have been Tuesday. So this is the logic that we'll be using for solving this problem. So when you, okay, so again I have, so if 22nd was a Saturday, then 23rd, acha, oh sorry, 2 days have been passed. 22nd, after 22nd, 2 days have been passed till 24th. So it will be Saturday, then Sunday, and then Monday. So 24th has to be a Monday. So this is the logic that we'll be using for computing the day of the day at a particular given year, particular given date. Okay. So let's say what about February 1? Let's say what about 5th February? What about 5th Feb 2020, 2000? What would have been done that day? So how many days? Many days have passed since 1st January? So we have 31 days in Jan and 5 in Feb. So total 31 plus 5, 36 days. Okay. In these 30 days, how many complete weeks have passed? They are 36 divided by 7. So we take an integer division. So double. So when we use double front slashes, then it represents integer division. So it returns the quotient of the division. So 7 for 7 5 is 35. So we have total 5 weeks. 5 Saturdays have passed since 1st January. Fine. And what were those days? What was the most recent Saturday? The most recent Saturday would have been 35th on 35th day. So that is 4th Feb. I mean 35th, not 35th, 34th day. And that would have been 3rd Feb. That would have been 3rd Feb. So let's see what was 3rd Feb. So 31 plus 5. I think there is some mistake in my understanding. That is 6. Ah, makes sense. Makes sense. Sorry. So there has been a mistake. So total 5 weeks have been passed since complete week since 1st January. And every seventh day, what it is a Friday. Every seventh day is a Friday. Fine. So 7th of January was a Friday. Then yeah, so every 7th. So after 5 weeks, so 35th day would have been a Friday. Thus, the 36th day is a Saturday. Now, we are talking about 36 days. So, 5th Feb 2000 was a Saturday. So the logic goes like this. Uh, in a week, we have 7 days. Monday. So let's say our week start with Saturday. Let's say. So our week start with Saturday, then Sunday, then Monday, then Tuesday, then Wednesday, then Thursday, Friday. Fine. So starting from the first day, Saturday, how many how till how after how many days we reach Friday? We reach Friday after 7 days. So if it was 1st Jan on Saturday, then on Friday it would have been 7th Jan. Similarly, so every 7th every day which is a multiple of 7 will be a Friday. Now till 5th is February, there were total 36 days. So what was the nearest multiple of 7? That was 35. So 35th day would have been a Friday. That means 4th Feb would have been a Friday. So 5th Feb is a Saturday. So let's look again some another example. Let's what about 5th March? Let's check 5th March. So how many days? How many dates from 1 to 1 Jan to 5th March? So 31st, 31 days in January, plus since 2000 was a leap year, 29 days in February, and then 5 days in March. So total, so no, it's just 60 plus 5, 65 days. Fine. So what is the nearest date? That would have been Friday. That would have been 65 double divided double full the front slash 7. So that would have been sorry 56 and 63. So that would have been 9. So ninth. So that would have been 9. So that means 63rd. So this division results in 69. So that means 63rd date would have been a Friday. Fine. So what would have been this 63rd day? That would have been 5th is 65th, 4th would have been 64th, then 3rd. So 3rd March was Friday. So 5th is Saturday, Sunday. So 5th is Sunday. So let's see if this is correct. So yeah, you can check. You can see here 5th March is a Sunday. Everyone, can you see this? And is the logic clear? So this is how we are playing this problem. So we know that our month of our year starts with a Saturday, and every seventh day should have been a Friday. So you can see 7, 14, 21, 28. Then 28 plus 7, which is 35, and the 35th day would have been 4. So this is the logic. Every seventh day, every date that is a multiple of 7, every day that is a multiple of 7 would have been a Friday. And then from there we can count the day. So let's write up a logic for this. So let's open up the spider ID for this problem. Right. Hmm, so pay calculated dot py. So yeah, now let's say we have a date. We have a date. So we can use Python date time. So let's import the Python date time module. Import date time. Now what we can say? We can say. So let's look at this library first in our terminal in the ID, and then we will see how this works. Okay, fine. So let's import date time. Now let's store the date in a string. And let's say we are talking about 1 Jan. So it's 2000. And so let's create a list that contains this information. The first value is the year. The second value is the month. Let's say first month. And then the second value is the date. So the format we are using is year, month, and then date. Fine. So now let's create a date time object of this date time dot date and pass in the date information here. Okay, so it can't. So let's pass in the year, then month, and then day, date. Fine. So now we have a datetime.date object. So let's try to extract some information from here. So yeah, we have the year this, and then we can get the month from here, and then day, I guess. So this is how we can use datetime, not date. So let's say we define a date like this using the date time dot date object. So first we have to pass in the month. First we have to pass in the year followed by the month, which is one, and then the day one. So when we can query that month like this, the year using date dot year, then we can query month using date dot month, and we can query day using date dot day. So let's create another day. So let's say 5th March. So date dot month would be 3 and date dot day would have been 5. Fine. So we'll be using date time for this. Fine. So let's say we declare a date using this format, and let's say we have our date as a okay. So we can also use strings to do this operation. So there is another feature from the date time. Let's say we have a string uh, date date in a string. It's which is stored like a normal way. YYYY space space date. Fine. So let's say our date string is it's 5th March 5. Then it is 3rd. So 5th March, and then the year was 2000. So we can compute the date using this operation, this function date time dot date dot from ISO format. So this function can be used to extract the date time and date information from this date string. So date string. Fine. Now again, we can see date dot day. It is 5th. Date dot month is 3, that is March, and date dot year, that is 2000. So you can use strings of this format to and use the function from ISO format to convert this to a date object. So let's use this. So let's say we have a date string, which is a string, and again we are talking about the year 2000. The month is, let's say, 5, which is May, and then 10th of May. Then we can get the date as follows. So date time dot date dot from ISO format. So you can see it's takes it takes a string of a date. So I can pass in date string here. So now we have a date. Now what we need day, we need the month information, which would be date dot month. Then we need the day information, which is date dot day. Fine. So we have all these informations. Now what we need to do? We need to compute total number of days passed since Jan 1 till day. Okay. How to compute that? So we have the month information. So date dot month. In the date dot month, we have that information. So we know that January is basically corresponds to month 1, and it has 31 days. Then Feb, for a leap year, it corresponds to month 2, and it has 29 days. Then we have March, which is the third month and contains 31 days again. Then April is the fourth month and it has 30 days. Then we have May, which is fifth month and has 31 days. Then we again have June, that is sixth month and has 30 days. Fine. Now, when we go to July, you see it is the seventh month and it has 31 days. From August onwards, it is the eighth month and it also has 31 days. Fine. So August also has 31 days. From August onwards, you can see the behavior that uh, every even even month has 31 days and odd month has uh, 30 days. Okay. So let's see 31 days. Then November is an odd month, so it has 30 days. Then December is the 12th month, which is an even month, so it has 31 days. So till July, what we saw that every even month has 30 days and odd month has 31 days, except February. Now, after July, we see every even month has 31 days and odd has 30 days. So we can use this logic to build up our function. So we can create a function def get let's say get days from Jan 1 and we get a date information. Okay. So first we need the month. So we can get month like this. Month equals to date dot month. Now what do we need to do? We need to count days. So let's say we declare a days variable as 0 and then we loop. So for I in range month. So what we are doing, we are counting total days till the previous month. What we have, if month, if I is less than equals to 7. So if I is July or month before, then if I is of February, that is second month, then days plus equals to 29. This is only for the year 2000, that is, it was a leap year. And if it's not February, then if I is an even month, then we have 30 days. So days plus equals to 30. Else days plus equals to 31. So every even month has 30 days or every odd month has 31 days. Now, after July, starting from August, what do we see? The pattern is flipped. So if I modulo 2 is 0, then we have 31 days and else we have 30 days. 30. So this is the logic. This is how we can get total number of days till the month, till the previous month. Now, how many days have passed in the current month? That can be get computed by days plus equals to date dot day. So this is how we get the total number of days, and finally we can return our total days. Fine. So let's check out this function and let's see if this is correct. So let's say we have a function present in a Python file name date calculator. So we can use this function from date calculator import get days from Jan 1. I think we are in the incorrect. Acha, it's day calculator, not date calculator. So let's rewrite from day. So the file is day calculator import get days from Jan 1. Fine. Now we need to declare a date. So let's say our date is a string, and let's say it was 2000 year. Month was March and 5th. Fine. So what we need today, we need to get days. We can call function get days from Jan 1. But we need a date in date time format. So we can import date time library, and we can get the date as date time dot date dot from ISO format, and we can pass the date here. Acha, our string was incorrect because it is TDMMYY, so it has to be 03 and then 05. Now we get our date variable. Now we can get the total number of days, get days from Jan 1 and date. So let's see what are the days. So it says total 95 days have been passed. So let's see. 30. So how many days? 31 in January, 29 in Feb, and then 5. I think there is some mistake. So let's debug it. So it is getting counting 30 extra days. So let's see where do we have the issue. So for I in range 1, so we have I in range 3 basically. So 0, 1, 2. Okay, fine. Now I get it. What's the issue? So the months are starting from 1, but our function loop was running from 0. So that's why we are getting that extra day. Let's call this function again and let's see. So yeah, now it is correct. So we have 65 days till this. So we have one function ready for us. Now what we need to do, now we are able to get total number of days from Jan 1. Next, what we need to do, we need to count we need to get this initial day and then get the day which it was. So how we can do that? So we can simply get the days, divide by 7, and get the total number of weeks that have been passed. So the total 9 weeks have been passed, and days divided by 7 is uh, so what do we need? Days modulo 7. So we are 2 days after a Friday. So that means the current date, so that is date dot day is so current date is date, which is 5th March. It should be a Sunday. So let's see if it's correct. So yeah, 5th March is a Sunday. So our logic is correct. Fine. So we are 2 days. So days modulo 7 gives us the number of days after a Friday, and that is 2, and that thus our day is a Sunday. Fine. So let's finish up the logic. Def get day of the week. Fine. And we pass in days as variable. So days, and again we need to give the initial day of the week. So what is the initial day of the week? We also need that initial day. Fine. So days after initial day, which is equal to days modulo 7. And then we can get the final day is equals to initial day of the week. So basically initial day of the week plus days after the initial day. Fine. And finally we can return day. So let's see if this function works perfectly. So from day calculator, okay, import get day of the week. And we have days here. So let's call the function get day of the week. And let's say our initial day was a Saturday. So basically that would have been a Friday, and Friday is the 7th day of the week. So let's define our week array also. So week days and declare a list of string. Let's say our string, our week starts from Monday. Then there is a Tuesday, then Wednesday, then Thursday, then Friday, then Saturday, then Sunday. Fine. And let's say our week starts from Monday. So what was the initial day after which we have to count? So initial day was a Friday, that is 0, 1, 2, 3, 4. Fourth day. It was the fourth day. And we have to pass in the days. We will get the answer. It says sixth day is the answer. Let's see. 0, 1, 2, 3, 4, 5, 6. So the sixth day, which is Sunday. So that is the answer. So now let's define everything in our main program and then run it. Fine. So let's define the main function here. So let's ask for the so date in a string format. So input, please enter the date in the YYYY format. So let's prompt the user for the date, then convert it into a datetime object. So datetime.date dot from ISO format. Then what we need to do? We need to get days from Jan 1 and we need to pass this date. Then we have to get the uh, weekday is equals to, so let's call it days. And then weekday is simply get day of the week. We have to define the initial day, which was the fourth day of the week, and then pass total days. Finally, we have to tell the user the day on your date, which is, uh, let's say date is or was, then it is weekdays at weekday. So let's run this program. Fine. So please enter the date in DDYYMM format. So it was year 2000. Then month was March, and then date was Feb. So what does it say? It says the day on to this was a Sunday. Fine. So let's check another day. Let's say what was 16th August on that year in that year. So let's see. So it says list out of range. So there is some issue in the code. Let's see. Hmm. 16th August. So there is some issue with the list. So let's see what are the issues. So let's check total number of days from Jan 1 first. So let's get days from Jan 1, date, time, dot date from ISO format. It was 2000 August 16. So 229 days. So let's count it. 31 in January, 29 in Feb, 31 in March, 30 in April, 31 in May, then again 30 in June, 31 in July, and then 16 in August. So 229, this is perfectly correct. So what is 229 modulo 7? It is 5. So it would have been fifth day. Acha. So logically, what would have been the fifth day from the starting date index, which is 4 plus 5, that is 9. 9. So what would have been that day index? It would have been 9 modulo 7 because the days can't be greater than 2. So there is some logical issue in our program. So let's correct it. So what has to be the day was weekday, that weekday modulo 7. So return day modulo 7. So why I'm doing this modulo operation here? Because every sixth day, the day changes to 0. After 6, again it comes to 0. So that's why we are using this modulo operation here. So now when we run the program again, we will get the correct answer. So the date was 20 August 16. Oh, 2000. Yeah. So the year was 2000, the month was 8, and the day was 16. So it says it was a Wednesday. Let's see if our answer is correct. So yeah, it was a Wednesday. So this is our program that will do this. So anyone, do you have any doubts in this program? Anyone? So this was the logic for writing for this program. So now let's say if you have this database, you can run this program over these days to get the correct answer. Fine. Anyone, if you have any doubts, please type in the chat box or we can proceed to the next problem. Am I audible? Is my screen visible? Anyone, please confirm. Fine. So do you have any doubts or should I proceed with the next questions? Fine. I should proceed. So let's go to the next question. What is the output of the following snippet of code? So fine. So everyone, can you see this code snippet? So let's take a break for 5 minutes and then we'll resume from this problem. Till then, please type in any queries in the chat box. And yeah, that's it. And try to understand this problem code. So, hi everyone, welcome back. Do you have the answer for this problem? So let's try to solve this problem. So are you familiar with it? List slicing in Python? Everyone, if you're not aware with this concept, you can type in the chat box and I'll explain it. So let me explain it in brief. So let's say you have L that contains name of some students. Let's say, uh, let's say I have a list of integers or maybe digits, decimal digits, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's say we have this list, right? So we have this digits list that contains list of digits. Then how do you get the list, sublist, smaller list that contains the elements from the index 0 to 4? So you can use this colon operator. What does this mean? This means to from starting take 4 elements, and this means from fifth index take remaining element. So this is how list slicing works in Python. Fine. So let's get back to our problem. So again, another hint is, let's say you have a list like this. So list A that contains 0, 1, 2, 3. And then you have list B that contains the remaining digits 4, 5, 6, 7, 8, 9. So how to create a list that contains all the digits? You can use the concatenation operation just by adding them up. So this is how list addition works in Python. Fine. So let's get back to our problem. So initially our program says L equals to, so L is a list. So let's solve this here and then I will update everything else. So L contains, so L is 90, 47, 8, 18, 10, and then 7. Then what does S contain? S is containing L at 0. So the value at the index 0 in the list L, which is 90. And we are creating a list containing that element. Now, for I in range 1 to length of L. So what is length of L? Length of L is basically 1, 2, 3, 4, 5, 6. Total 6 elements. So length of L is 6. So we are iterating from 0 to 6, and we are declaring a flag variable which is true. Again, what is len of S? Len of S is 1. Now, if len L at I is less than S as J, before J is elements in S, before index J. So I think I will have to write this program for you guys. Then only we will be able to do this. Let me type in the program for you guys and then we'll solve this. So we have a list that contains the value 90, 47, 8, 18, 10, 7. Then we have list S that contains the element at the index 0 of the list L. It's a list containing one element. For I in range 1, comma length of L, what we have to do? Flag equals to true. Then for J in range length of S, if L at I is less than S at J, if this is the condition true, then we declare a variable before J, store the values, s at all elements until the index j. Fine. Similarly, new j is equals to L at I, a list containing one element, that is L at I. Then we have after j, which is equals to s at list starting from j in the s until the end. Now s equals to before j plus new j plus after j. Fine. Now what we do? Flag equals to false, and then we break. Now finally, if flag is true, then s dot append L at I. That's it. And finally, what we have to do? We have to print. So let's see what our program does. So what is the length of L? L is 6. So basically list range goes from 1 to 6. S contains a list that contains the value 90 right now. Now flag is true. For J in range, length of S is 1. So basically the loop goes from 0 to 1. 0, basically only 0 because it's upper limit. Then is L at I less than S at J? So what is L at I? I is currently 1 and J is 0. So is 47 less than S at J? J is basically 0, basically 90. So no, this condition is false. So what we have to do? We have to check if this is false, if this is true, it is not true. So this condition is true. So now what happens? We have before j is equals to s at all elements in the index j, and j is 0 right now. So j is 0, so basically 90. Then after new j is l at I. So I is basically 1 right now, so that is 47. Then after j is s at j till j until the end, from j till end. So 0 to end. So before j is blank right now, because slicing works, j is the upper limit. Now s is after j is s at j till end, so basically 90. Now what is s right now? Now s becomes before j, which is blank, plus new j, which is 47, plus after j, which is 90. So it becomes 47, 90. Flag becomes false, and we break the loop. Then flag is false, so this does not get executed, and I becomes 1. When I becomes 1, flag is true. Now j becomes 0. Len of s is now 2. So j goes from 0 to 1. Now L at I is less than j at 0. So now I is 1. So 47 is less than s at 0. This is false. So what happens? This does not get executed and j becomes 1. Now L at 1 is less than j at 1. J at 1 is 90. This is true. So basically 9 L at 1 is 47, which is less than 90. Now before j becomes s at 0 till 1. So basically 47. It is 47 now. New j is L at I is 1. So basically 47. And after j is s at 1 till end. So basically 90. And now s becomes before j, which is 47. New j, which is 47. And after j, which is 90. Now flag is false, break, and this does not get executed. So now when I becomes 2, the loop gets repeated. And let's see which options match. Hmm. So everyone, can you see what this program is trying to do? It is trying to sort the problem, sort the list. So we are taking the first element of the list L, then we are iterating through all the elements present in the list S. If the particular element in the list L is less than list S, we have to append it to list S. If that's not the case, what it does, it ignores it and simply appends L at I. So this is essentially what it's doing is it is sorting the list. So let's run the program and see what happens. So let's run. You can see 7, 8, 10, 18, 47, and 90. So it is basically sorting the list. So the correct answer is option C. Fine. Anyone, do you have any doubts? So this program, what it is doing, it is taking one element at a time from the list L, then comparing that element with the rest of the elements in the list L. If that element is less than the list of the element in the list L, then we have to append it to the S list and then extract the next minimum and repeat this step until we get the sorted list. So it's basically doing sorting. Fine. I think we can proceed. If no one has any doubt, then we can proceed with the next question. Anyone? Fine. Let's move to the next question. What does the random.choice function do? So what does it do? It generates a random integer false. It selects a random element from a sequence. That's true. It does not use the random floating point number. It does not generate a random Boolean value. So correct answer is option B. Option B. Random choice dot choice function, what it does, it selects a random element from a sequence. Fine. So let's move on to the last question. Identify the magic squares from the following. So we have to check if the sum of the entries in the row is equal to sum of entries in the column is equal to sum of entries along the diagonal. So let's look for the first uh, square. 1, 14, 15, 4. The sum is, let's check the values. 1 plus 14 plus 15 plus 4. 34. Then let's look at on the diagonal. 112, 8, 13. 1, 1 plus 12 plus 8 plus 13. So it's 34, and let's say 1, 7, 10, 16. So yeah, so this matches. So let's write up a program that takes up a list like this and checks if it is a magic square or not. And then we'll get our answer for all of these problems. So let's call it check magic square. Fine. So let's declare a list. So let's declare a square, which is a list of lists. So we have 4 by 4. So let's declare the 4 rows. The first row is 1. So let's create the list first. So which is 1, first row is 1, 14, 15, 4. The second row is 12, 7, 6, then 9. The third row is 8, 11, 10, 5. Then fourth row is 13, 2, 3, 16. So now what we have to do? We have to check sum across rows. Then what we have to do? We have to check sum across columns. Then finally, what we have to do? Check sum across diagonals. Fine. So let's start. So let's first compute the number of rows and columns. So total rows equals to len of square, columns equals to len of square at 0. So we get total rows and columns for I in range rows or j in range columns, right? So what we have to do? We have to compute the sum across the rows and columns. So for each row, what we have to do? Compute. We have to compute row sum. So we can directly use the sum function. So row sum equals to sum square at I. Fine. And let's take the reference sum value. Some magic. Let's compute the magic number. If it's true, it should be sum of the first row, elements in the first row of the matrix. Fine. So row sum equals to sum of square at I. So for each row, we are adding up the values. So if let's create a Boolean variable is magic square and initially declare it to be false. Now if let's declare it to, let's assume that it is a magic square, and we'll check if any on all of the condition does not hold, then it is not magic square. If row sum not equals to magic number, then it is not a magic square. Is magic square is equals to false. Fine. So this takes care of all the rows. We have to do the same for columns. So let's declare another variable call sum equals to 0, and for I in range calls for j. So for each row we have to iterate through. For each column we have to iterate through each row, entry in the each row. So call sum plus equals to square at j comma I. So this will do the same. This do the required. And now if column is not equal to magic number, it's not a magic square. So this is how we check across the columns. Now finally, what we have to do, we have to check across the diagonal values also. So for I in range rows, for j in range columns, what we have to do, we have to compute the diagonal sum. No? So let's declare another variable, diagonal sum, and set it to 0. Tag sum plus equals to. We don't know we don't need this internal loop also, because we know we are only dealing with I comma I indices. So is equals to square at I comma I. Fine. Similarly, now again, if diag sum is not equals to magic number, then again is magic square is false. Finally, we need to check the cross diagonal. So let's say cross diag sum equals to 0. Okay. For range rows, so cross diag sum plus equals to square at. So cross starts from 0 comma 1. 1 comma 1. No, 0 comma 2. 0 comma 2. So the row calls minus I. So this should work. So 0 comma 2, then I is 1, so calls minus I is 1 comma 1. I is 1, so calls is 3. Acha. So calls minus I minus 1. So yeah, now one when with y is 1, then it becomes 2 comma 2. I is when 2 and becomes 3 comma 0. Now again, if cross diag sum is not equals to magic number, is magic square equals to false. Finally, what we have to do, we have to simply check if is magic square, print the input is a magic square, else print not a magic square. So let's say our first square is a magic square or not. Let's run it. Acha. So yeah, I have made some mistakes in accessing the list indices. Fine. So let's run it. So it's saying not a magic square. How is that possible? So let's check a few things. There is some bug in our code, most probably. Let's first print magic number and print. Let's isolate the issue. So let's say if the row test is working or not, is magic square. Okay, so row test is not working correctly. So row sum equals to sum of square at I. So what is row sum then? Let's print the row sum. Okay. So I think there is some issue on my side. 13 to. So let's check the values. 8 plus 11 is 19 plus 10, 29 plus 5, 34. Yeah. So this is not a magic square. The code is perfectly fine. So this is not a magic square. Fine. So yeah. So this is correct. So first grid is not a magic square. So let's look at the second one. It is 16, 2, 3, 13, 5, 11, 10, 8, 9, 7, 6, 12, 4, 14, 15, 1. So let's say if this is a magic square. So yeah, the input is a magic square. So option B is correct. Then again, you can check for the remaining two also, and you will find out that I think. So you can check this on your own. So you have the logic to solve this problem. Then you can check if this is a magic square or not. Fine. So let's go ahead and check the third and fourth grids also. So this the second one is, let's write the answer. Option B. Let's check for option C. It is 7, 12, 7, 12, 1, 14, 2, 13, 16, D, 11, 6, 9, 4, 15, 8, 5, 10. So let's check this. It is saying not a magic square. So third one is also not a magic square. Fine. So let's check the last option. So you can check the remaining ones also. So we'll find out the first one is also correct. Okay. So let me check if there is some issue. 1, 14, 15, 4, then 12, then 7, then 6, then 9, then 8, then 11, then 10, then 5, 13, 2, 3, 16. Let's check. So yeah, the first one is also a magic square. Huh. So option 1 and option 2 are magic squares. Similarly, you can check the remaining two, they are not a magic squares. Okay, fine. So there are some practice programming problems that you can solve after this session. Till now, if you have any doubts, you can type in the chat box or we can end the session. Anyone? Do you have any doubts? This was week 4. Fine. So if you don't have any doubts, then we can end this session. So yeah, all the links will be shared with you by the NPTEL team. Don't worry about that. So yeah, someone is saying you can understand individual concepts, but cannot write code. So I mean, you can. It only comes after practice. So as you start practicing more and more problems, start to write code for more and more problems, then only you will be get familiar with coding. So yeah, it will take time, like practice, and it will take your time. So yeah, let's